Number 26, right? From the from the homework. Thank you.
Are we doing questions?
Doing number 26 right now. All right, so let's take a look and let's mark some stuff up, right?
Everything has dashes.
Yep, lots of dashes, aren't there? And they did it in the book already. You want to keep the same dashes they did in the book?
Yeah.
Okay, so the first one, HL and HM, they put 1 and 1, right? Then the next one, PM, they put 2, so PM and KL or LK are 2 of them. And then PG, this one right here is 3 of them. And so is KJ. And then what? GH is 4 of them. 1, 2, 3, 4. And then JH, 1, 2, 3, 4. There we go. And we're trying to prove, look we're trying to prove. We're trying to prove something a little different than what we had done before. Before they just said prove the triangle is congruent, right? But now we have to prove one angle is equal to another angle. So let's look at that angle first. Let's look at G and J. So look at G, this one right here. I'm not going to mark it, okay? Because I don't know that they're equal to each other, right? But I tell you, we could. I mean, if you wanted to, I don't think I've done this before, but you could. Let's mark it with a different color. Now we don't know this is equal. You follow me? This is what we're trying to prove, and I almost hate to do this, but we'll do it anyway. So I'm trying to prove that this angle is equal to this angle. Make sense? So yes. No, you can't assume anything. Said they're always equal? We never said anything about the angles always equaling each other. No, you can't assume that.
If every single side is the same, how is it even possible for them to
Yeah, but you gotta tell. Now, so look, you can't make any assumptions. You cannot assume anything about this. Okay, you can't just assume that G and J are equal to each other. All right. What do you think we want to do though? I tell you what. Let's do this. Let's put this on hold for a few minutes. Okay. Let's go to something a little bit easier. And I'm just going to do this. I'm just going to grab this triangle. So we'll put this on hold. I'll come back to it, alright? So don't flip out on me here. So let's do this. I'm going to make this really super easy for you. I hope. Copy and paste. So I got 2 triangles right here. Okay? Now let's label them A, B, C, D, E, F. Alright, they're not overlapping, they're not twisted, nothing, okay? They're just right next to each other, really, really simple, okay?
Sorry.
You alright?
Yeah.
Okay. If you need to get a drink of water, you can.
No, I'm good.
Alright, so watch this. What if they told you that A, B, and D, E were equal? What if they told you that A, C, and D, F are equal, and they told you that B, C, and E, F are equal? Alright? And they want you to prove that... let's say angle A is congruent to angle D. Let's think about this. So what do we know about the triangles right now? We know the triangles are congruent, don't we? Give me a reason why, though. Side, side, side. That's what we say. It's really the only thing you want to say is side, side, side. The 2 triangles are congruent because of side, side, side. Now, if these 2 triangles are congruent, if I took this triangle, picked it up, sat it on top of this triangle, we already know the corresponding sides are all equal, right? But what else would be equal then? If I know that these triangles are congruent, so now I know that triangle ABC is congruent to triangle DEF. And why? Because of side, 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 right? So if I know these triangles are congruent to each other, what else do you think that I know about this triangle? So if I know these 2 triangles are congruent to each other, if I took this and picked it up, oops, let's do this. There we go. If I took this, I'm going to group it together so I can move it. And I took this and I picked it up and I put it right on top of the other one. It matches up perfectly, doesn't it? So we already knew that the sides were all equal, right? But what else do we know about this? that the angles are going to be the same as well, correct? Am I right on that? So we already proved the triangle's congruent, so if I wanted to prove that that angle A was equal to angle D, I can say that now. Why can I say that? Why are these two angles equal to each other? I've already proven the triangle's congruent. Remember that. I've already proven the triangles are congruent to each other, so why can I say that angle A is equal to angle D? Because no, it's side, side, side because we already used side, side, side to prove the triangle's congruent. We only use side, side, side and side angle side to prove triangles congruent. We would never use this to prove that one angle is equal to another angle or one side was equal to another side. Okay, this is only a reason and a proof to prove that triangles are congruent to each other. But we talked about this in class before you even started today. It was brought up. What do you think, Alex? Say the first part of it again. No, it's not congruent. Okay, you should look this up in your notes. Okay, it's CPCTC. Okay, but you got to know what these words stand for. There's 3 C's in here. Okay, right. 2 of them are congruent. Okay, those 2 words right there are congruent. But what's the first word? It's corresponding. Okay, it's corresponding parts. I'll shorten everything. Of what? Congruent triangles are what? Congruent. Corresponding parts of congruent triangles are congruent. That's what that means. So, I want you to understand what it means. I don't want you just to look at it and think of a whole bunch of words that all go together and okay, we just use that. Understand what it means. Look at A and D. I picked this up and I put it on top of it. So A and D matched up, or they did what? What's another word here that means matched up with each other? They correspond to each other, right? You don't see that? Look, listen to the words I said. I said A and D match up with each other, right? They match up with each other. So they must be, what? Corresponding angles, right? Or they're corresponding parts. You see that? So A and D are corresponding to each other. Well, what else is corresponding to each other? 5 other things. What else? B and E. Angle B and E are corresponding to each other. C and F correspond to each other. AB and DE, those 2 sides, they correspond to each other. Do you see it? Because if I picked one up, stuck it on top of the other one, they would match up. Everybody got that part? So A and D are corresponding angles, or they're corresponding parts. Okay, because angles and sides are parts of a triangle. So A and D are corresponding parts of, now we just proved, didn't we, that these triangles are congruent. So guess what A and D are? They're corresponding parts of what? Congruent triangles. You see it? So corresponding parts of congruent triangles, what must be true about those 2 parts then? They must be congruent or equal to each other. Okay? Does that make any sense? So we only use side, side, side and side angle side to do what? To help prove what? As a reason for triangles being congruent to each other. Everybody see that? So we would never use side, side, side to prove that an angle is equal to another angle or a side is equal to another side. This only is good to prove that 2 triangles are congruent to each other. Does that make sense? What if I said prove that angle B is equal to angle E? What reason would I use to say that angle B equals angle E? Yeah, corresponding parts, right? CPCTC. Let's do another one. Grab another type of triangle. Actually, let's do obtuse just for fun. I think that's an obtuse right there. Watch this. Okay, here's a nice obtuse. I'll do this, do this. I'm just going to make up my own little problem here. And let's rotate. Or no, I don't want to rotate it. What do I want? I want to reflect it. There we go. Alright, so let's do that. This is getting a little bit closer to what we, are trying to accomplish. So let's do this. I'm not going to write down all the given and all that kind of stuff, but what if they said, let's say this side was equal to this side, okay? And then they said that this angle equals this angle. And they, for some reason, they told you that this side was equal to this side right here. Everybody with me so far? Alright, so let's just label these and label this like this. Okay? So they told you, or you were able to figure out that all that stuff was true. So now, with all that stuff true, what is true about these two triangles? What could I say? Triangle PQR is congruent to triangle. Now, if I go PQR, what am I going to have to do over here? ZXY. Good. Now, they're congruent to each other. What would the reason be for these two triangles being congruent to each other? Side, angle, side. Very good. There's a side that's equal to a side. There's an angle to an angle, side and side. You get it? And the angle is included, so it's side, angle, side. That's my reason. What if, though, they said to do this? What if they said to prove that angle Q was congruent to angle X? What would your reason be for that? Now, we've already proved that the triangles are congruent. That's already done. That's in our proof, okay? Because we did all the given stuff, right? I'm leaving some stuff out, but we wrote all the given. We said, you know, PR is equal to ZY because of given, and then this angle R is equal to angle Y because given, and so on. And then we said, okay, the triangles are congruent because of side, angle, side. But we're trying to prove that Q and X are equal to each other. So right after I say they're congruent to each other, then I can say Q and X are equal for what reason? CPCTC, okay? Because of corresponding parts. Usually in my classes, I like students to not say CPCTC. You can write it down that way. But to verbally say, because they're corresponding parts, right? You don't have to go through the whole thing. Corresponding parts of congruent triangles are congruent. You can, if I just said, why is angle Q equal to angle X? You would just say, what? What would you say? Because they are what? Corresponding parts, okay? Does it make sense? You could also prove something else. You could also prove that angle P is equal to angle Z. What would your reason for that be? Yeah, if I asked you to prove that angle P was equal to angle Z, what would your reason be? Because the corresponding parts of congruent triangles are congruent. CPCTC, right? Because they're corresponding parts. I could also say prove that PQ, line segment PQ, is congruent to line segment XZ. What if I asked you to prove that? Because they don't tell you, do they? They don't tell you in this proof that PQ and XZ are equal to each other, or ZX, whatever. I did that in the wrong order. I should do this in the right order. Sorry. So, let me write this down first. Okay, ZX. So, why are those two segments equal to each other, or congruent? Because of what? You guys following along? I got like one person helping me out here. Because of what?
Corresponding parts.
Yeah, because of corresponding parts. Okay, we're trying to establish a little pattern here. Okay, do you see the pattern? All right, every one of these. Why is R, or sorry, not R, but why is P equal to Z? Because of what? Talk to me. Corresponding parts. Why is Q equal to X? Because of corresponding parts. Why is line segment PQ equal to line segment ZX? Because they are corresponding parts. Okay? Does that make any sense? So, I first have to prove the triangles are congruent, then I can say that the corresponding parts are equal. You got it? Let's go back up to that original proof. You guys are dead today. What's going on? That's no excuse. Alright, here we go. Let's take a look at this. So what are we going to... We're trying to prove that these two blue angles, G and J, are equal to each other. So what do you think we need to do first before we can say that angle G equals angle J? We need to show what? Say it. Prove that the triangles are congruent. Exactly right. Let's prove... Well, there's a lot of triangles in there, aren't there? So let's try to see which triangles that we're dealing with, okay? Well, there's actually... This angle is a part of what triangle? It's really only part of one triangle, isn't it? Let's write it down. So triangle, what is it? GLP? What? Say it again. Okay, L. I'm sorry. I was looking somewhere completely different. You're absolutely right. So GPL, good. Okay, GPL. Everybody see that triangle right there? All right, it's, tell you what. I can do this with the magic of my little thing here. And do this. Okay, good. Watch, I'm just going to change the color. What color do we want to make this triangle? Purple? I heard purple. So let's make this purple. Let's make... Well, it's purple on my screen. If you look at it, which one do we use? That one? Raspberry. That's... No, we didn't use raspberry. We used that, which is amethyst. Or did we? Does that look like the same color? We'll make it the same color then. Amethyst. We'll use that one. Okay, we'll use that first. There we go. That looks like the same one. And then, well, we got a little problem here because this is going to overlap, but that's okay. We'll just do like that, okay? Because this one's got to be 2 colors, and I can't make them both 2 colors. All right. So do you see the purple one, the triangle? And then let's make this triangle a color. What are we going to make that one? Gray. Oh, that's boring. You said green? Okay, we'll use green. So what green is that one? That's little sprout green. That's funny.
Yeah, it's like over.
Wow, I sure did, didn't I? Oh, you know why? I know why, because I didn't. I know. I know. I will. But the problem is, I know why, because I didn't ungroup that triangle. So watch. You probably have no idea what that means. I'm just going to make this one white. Okay, so there we go. All right. The white one is shared by both of them. Do you see that? All right, and I kind of like that, to tell you the truth. So let's see. Let's see how to make these triangles congruent to each other. GPL is one of them, right? That angle is in GPL. What do you think the other triangle is? I'm just jotting these down just so I could see it. If I call this GPL, what would I call this green triangle? JKM. All right, so it's JKM. JKM. All right, everybody see that? You got the purple and the green. Got it? If we could show those 2 triangles congruent to each other, then guess what must be true about G and J? Yeah, they're corresponding angles, and so they must be equal then, right? So the whole gist of this is to take the 2 triangles. No. There's no need to do that now. I'm right in the middle doing something. Crinkling up the paper was bad enough. I didn't even say anything. Okay. So look, G and J they need to be equal to each other. And if I can show that these 2 triangles are congruent triangles, yes. Yes. If I can show that these 2 triangles right here are congruent to each other, then these 2 angles will be equal because of corresponding parts. Does that make any sense at all to you? Okay. So how do we do that? Well, let's see if we got some sides. Look what we got so far. I got GP equaling JK. That's one side, isn't it? I got this one right here. L, right? See this big long one right there? I kind of do. You got to do a few things first. Let me see something. Yeah, there's a whole bunch of stuff you got to do with this. So it gets a little complicated. But basically, GL is going to be the same as JM. But it doesn't really say that, though, does it? It says GH and what? HL, right? They add up to be the same thing as what? JH and HM. Everybody see that? So if you add these together, and that's called the addition property. All right. So if I add the same 2 things, for instance, if I add like a 3 plus 2 over here, and I add a 3 plus 2 over here, what's going to be true about both of those things? They're going to be equal to each other, aren't they? Do you agree? All right. So it's kind of like the same thing here. If I add this to this, and I add the same 2 things together over here, you're going to end up with 2 equal things, right? So you have to establish that. That's a little bit lengthy. So we'll still do it, but you got to think about that. So now we got those 2 sides equal to each other. What about down here? We can kind of do the same thing. But do you see ML? ML is shared by both of these triangles, isn't it? So watch this. Look at P. Well, it is reflexive. So let's do this. Let's do, well, we got 4, don't we? So I hate to do this, but 1, 2, 3, 4, 5. Now watch what we have. Do you see PM plus ML? Isn't that going to be equal to LK plus ML? Yeah? It's kind of like this. It's kind of like saying 2 plus 5, right? Call this 2 and call this 5, all right? Since there's 2 marks and 5 marks, is that all right? So if I said 2 plus 5, wouldn't that be the same thing as another 2 plus 5? Do you see it? I just made this up. This 3 plus 2 is just numbers I just made up. Forget that. All right. Look at this right here. It was just the 3 plus 2 is just to show you that if you take two things and you add them together, then you take two of the same things and add them together, those two things are going to be equal to each other. That's the only reason that I wrote the 3 plus 2. All right. But right here, I'm writing 2 plus 5 for a reason. I'm writing this 2 and this 5 equals this 2 and plus this 5. Do you see it? Yes. Well, no. I'm just jotting stuff down. I'm just jotting stuff off the top of my head. I'm just writing stuff down right now. Okay, so I haven't even done a statement reason thing. So just bear with me. Yes.
Could you say that H is the midpoint because, like HL and HM are?
You don't need to say it. No, you don't. It's not a midpoint because look, because this segment right here and this segment right here, they're not necessarily equal to each other. So no, H is not a midpoint. We're not going to say anything about that. Because if H was the midpoint, then this would have one arc and this would have one. Not arc, but tick mark, right? So it's not the midpoint. So it's definitely not the midpoint. Yes. Yes. Anybody else want to leave? Goodness gracious. Okay, no, stay where you are. Okay. I've had too many disturbances. You can't get a coherent thought here. So, what have we done now? We've got one side equal to one side. Let's do this. Let's say, let's go blue. Watch. We got this side, do you see that? Equal to this side. Agreed? That's just given. That was easy. But then we had to get GL equal to JM. Now, how did I do that? Well, I had to add those two things together, didn't I? So I had to say this one plus this one equals this one plus this one, right? So I had to do an extra step, but eventually I got those two sides to equal each other. So that side is equal to that side. I'm talking the whole GL and I'm talking the whole JM, all right? What else did I need to show? I needed to show that PL, right, was equal to what? KM. I needed to show those two were equal to each other. But first of all, I had to take PM plus ML and set it equal to KL plus LM. You see it? Once I did that, I showed that those were equal. So this side from here to here is equal to this side from here to here. So why are the triangles congruent now? Side, side, side. Okay, so I've got the triangles congruent because of side, side, side. Now, if the triangles are finally congruent to each other, then what's the final step as far as G and J being equal to each other? They're corresponding parts. Exactly right. CP, CTC. Exactly right. Okay, so this one was definitely a lot more steps. But I tried to make it so that you could kind of see it before we started writing anything down. Remember yesterday I said when you do these proofs, you don't want to just start writing down statements and reasons. You really want to go through it in your head. All this stuff right here was just stuff in my head just to kind of keep straight of what I wanted to try to do. All right? So my whole goal was to prove that GPL, triangle GPL, was congruent to triangle JKM. That was my whole purpose. And you had to do quite a few things to figure out that those triangles were congruent to each other. Once they're congruent to each other, then it's a piece of cake saying that angle G is going to equal angle J because it's just corresponding parts. So the whole gist of this was to prove the triangle's congruent, even though they don't tell you. They didn't tell you to prove the triangle's congruent, did they? But you had to look at it and figure out that's really the only way that you can get G and J equaling each other if the triangles were congruent and then the corresponding parts were equal to each other. Okay? So let's start writing some stuff down now. All right? I don't think I have enough room to do this. I can actually make this a little bit smaller. How's that? Isn't that cool? And then, so now I can see, now I got a little bit more room to write. So where are we going to start with this? Let's do a little Let's do it up here. Like this. Okay? And statements, reasons. I'll just do it like that. Yes. So look at the statements. What are we going to do first? Well, we want to prove the triangle's congruent. So what's the easiest thing to say first? That GP is equal to JK. All right, that's what I would say, right? And there it is right there. Now I said GP, but you can say PG. It doesn't make any difference, does it? So I'm going to use that one first because I want to go in order side, 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 and I think that's the easiest. So I'll call it GP. I'm fine with that. So GP is congruent to JK. And why? It's given. All right, so I got one side, and that's actually one of my sides, isn't it? You can, let's do this. That's one of my sides, right? Let's find one of the other sides. What you want to do next? Let's do GL. Let's do that one, okay? But I can't just come right out and say that GL equals JM. I first have to say that this angle is equal to this one, right? And then I got to say this one is equal to this one. I got to say that first. Because what am I going to do to those? I'm going to add them up, aren't I? So we got to say that stuff first. So we still got to say that GH is equal to JH. All right? And I also have to say that, what do we call this? HM? Let's call it HM. Oops. HM is equal to HL. And why is that all true? Because it's given. Do I put a little S here? Is that one of my sides? No, because it's not my whole entire side of the triangle, is it? So I got to wait until I do that. So I've got that stuff equal. So I've got this 4 marks equal to this 4, and I got this 1 equal to this 1. Everybody see it? So now what can I do, though? I can take GH plus what? HL. Again, pretend this was 4 and this was 1. So I could take 4 plus 1 and then do what to it? Set it equal to another 4 plus 1. Now don't put the 4s and 1s in there. I'm just doing that to get you to think a little bit. Does that make any sense? If this is 4 and this is 1, and then I take another 4 and 1 and I add them together, what's going to be true about this 4 plus 1 and this 4 plus 1? They're going to equal each other, right? But instead of putting 4 plus 1, what am I going to put in here? I'm going to put GH, watch this. This is the new stuff. GH plus what? This is the 4 and this is the 1 plus HL, correct? That should equal what? JH, because that was the other 4, wasn't it? Plus HM. Do you see that? So look, GH was equal to JH, wasn't it? Those are both the same. HL is equal to HM. So if I take take two things and add them together, and then over here I take two of the same things, add them together, what's going to be true about the sums of those? They got to equal each other, right? So right here was just, let's see what they use for this, to tell you the truth. So right here would just be the addition postulate. So I'll just put I'll put add and then postulate. We have a thing, and you just heard about it today. They might have talked about it in chapter 2 that we skipped, okay? But I figure I'll just tell you about it today. It's easy enough. So if I add two things and I add two equal things to them, they're going to equal each other. That's what the addition postulate says. So we can add those together because of the addition postulate. Now look at this. Look at this right here. What is GH plus HL? 4 plus 1 is 5, right? Or GH plus HL is equal to what? The whole entire thing. What's the whole entire thing? GL. So I could take this, instead of calling it GH plus HL, I could call it what? GL. And what do you think I'm going to do over here? So that didn't look very good. Let's try this again. There we go. So JH plus, watch, JH plus HM, what's that going to equal? JM. Okay. Are they my two sides I wanted to show equal to each other? Absolutely. That's this one purple side and this one green side right here. Do you see it? I wanted to show them equal to each other. So guess what that is? That's my other what? That's my other side. So I can put my other side right there. So it took a little work to get to it. But did you see what we did? I just had to show that I added them together, and once I add these together, and once I add these together, then the two whole things are equal to each other. And that's what I did right there. Okay? Let's keep going. I can't really scooch down anymore because I want to see my picture. What else do I need to show? I need to show that PL, right, is equal to what? KM. I need to show that. But I can't just write that out right now. I have to show why it's true. So what are we going to do? I'm going to add PM to ML. But before I do that, though, this is a little tricky. I have to say something. Let me keep this in blue. I got to say something about ML. Because ML is the same on one side as it is on the other. So why is ML equal to ML? Reflexive property. Okay, so I have to state that. And that's reflexive. Oh, by the way, what was the reason for this? I didn't write the reason. This was what we call substitution. Because GH and HL are basically the same thing as GL. Do you see it? If I add those two. So we call this by substitution. Substitution. Alright? So that's the reason. All we did was just rename this, didn't we? It's the same thing, isn't it? GH plus HL is the same thing as GL. JH plus HM is the same thing as JM. So all we did was rename it, and that's substitution. We just substituted another name in for that. What about ML equal ML? We already said that. It's reflexive. That's a nice easy one. Reflexive property. Alright, so now you know that this ML on this triangle is equal to this ML on the other triangle. Now, we can kind of do the same thing as what we did earlier. So now it should make a little more sense. So what do you think we're going to do to get these two sides equal to each other? We're going to do what? You got it. See? PM plus ML equals what? Let's go this direction now. KL plus LM, right? So KL plus LM. What allows us to do that? What allows us to take these two things and then these two things and add them together? No, no, no. I took this plus this. It's addition postulate. Look, okay, it was addition. That's what we did, isn't it? Right there. So again, we'll call that the addition postulate. We're almost there. We really are. Like 2 more steps. So what is the same thing as PM plus ML? PM plus ML is the same thing as what? PL. So what I can do now, I can say that PL equals, what about this one? What's the same thing as KL plus LM? KM. And what's my reason for that? Substitution now, right? That's substitution. What did I just find? PL and KM. I wanted that, didn't I? I wanted PL. I wanted KM to equal each other because that's my third side. That's right. That's my third side. So I can come over here and put that little S there. Now, check it out. Let's get rid of that stuff. Okay. Now look at this. I've got side, side, side. So guess what's true about those two triangles? They are, oops, a little too far. They are congruent to each other. So what did I call it? GPL, right? So it's triangle. GPL is congruent to triangle. Let me scooch it up a little bit. What? If I went GPL, I got to go what? JKM. Alright, so it's JKM. Now what's my reason for that? Side, side, side. Exactly right. Am I done? Am I done? Is that what I wanted to prove? Did I want to prove that the triangles were congruent? No, I wanted to prove what? That those two blue angles were equal to each other. Okay? So now that I've proved the triangle's congruent, now what can I say about angle G and angle J? Now I can say that that's right, and so we're done. Okay, so now, was it G and, was it again G and what? G and J, right? So angle G is congruent to angle J because of corresponding parts of congruent triangles are congruent. Look at that. Now that is a heck of a proof. Okay. That is one heck of a proof, isn't it? Above this? I don't know what you're talking about.
The little, like the little things in the front? No, like they're little scrolls.
Like that? So keep going up? Is that what you're saying? I don't see what you're talking about.
Like, do you have the little things like in the middle of the page instead of making it like the top? Like it's saying how you're in the middle of a big page.
I don't. And the scroll it like this right here?
Yeah, like that thing isn't at the top, it's in the middle.
Right, because there's all that stuff. It's all, watch, I could make this smaller and smaller and see, that's the page so I'm only working with that much right there.
Why don't you make it bigger?
Well, because it doesn't all fit on the screen. It's good like that, right? So that's what I'm working with right there. That's why the bar is in the middle. Okay. See, go like that. So go all the way out.
Yeah, go all the way out and then put
and
the
make a
point on the
point.
back.
Okay, let's make it in a color. What color? Blue. Okay, so there. Is that small enough?
Oh my god.
And then boom, boom. Oh, it's all squiggly. Look at that.
It's not even a dot.
It's not. Yeah, it's not even a dot. You see all the. So that's
Keep going up.
what it looks like right there. So anyway. Yep. There you go. All right. Well, we've had fun with that. Everybody got all that stuff down. There it is, right there. It's all there for you. Yeah, that'd be great. All right. So there you go. Wasn't that fun? Now now you can really say you did a real proof right there. Yep. All right. So you're getting a worksheet. Work on that worksheet tonight. We'll go over that tomorrow. Okay. Yeah. Turn in your homework.